Hi, this is lesson 1-1, properties of frames, or properties of numbers. So we're going to do a quick frame, complete a quick frame on the different properties of numbers. These should be a review. And then we're also going to talk about the types of numbers. So this frame is about the properties. Ooh, and that's a little too thick. It's about the properties you need to know and types of numbers. So this really should be a review for you. It will be on the test, so we need to make sure you know it. Let's look right here at the far right-hand column where we have irrational numbers and rational numbers. So you notice right here we've got this kind of funny shape, and I want you to put in there real numbers. Both rational and irrational numbers are real numbers. Real numbers are pretty much anything you can think of. We do have imaginary numbers, but all of them that we're going to talk about for now are all real numbers, and they're either rational or they're irrational. And irrational numbers are numbers that cannot be written as a fraction. Okay, that's one way we know it's an irrational number. And it also can only be a non-terminating, so never-ending decimal. So to be irrational, you cannot be able to write it as a fraction. So 1/2 is not irrational. And you can only write it as a fraction or a decimal that keeps on going. It's got to be a non-terminating decimal. Down below that, rational numbers, these ones can be written as a fraction. Okay, so like 1/2, 5, -5, 12, -3, those are all rational numbers because we could write those all as a fraction. So we've got a couple categories under rational. We have integers, and these are numbers like -2, -1, 0, 1, and 2, and then they keep going in both directions. So we have positive and negative numbers. And then we also have whole numbers. Whole numbers are the numbers that kids start counting with, except for we add 0 as well. So whole numbers are 0, 1, 2, 3, and so on. So all the numbers that we can think of are real numbers, and we break those down into irrational and rational numbers based on whether or not they can be written as a fraction. And then under rational numbers, we also have integers and whole numbers. Let's look over at our properties now. We've got 6 properties that you need to know and to be able to recognize. The first one is the closure property. So for most of these, we're going to do one for addition and one for multiplication. So the closure property of addition tells us if you have a plus b, so you add 2 real numbers, so a plus b is a real number. If you add 2 numbers, your answer is going to be a real number. The closure property of multiplication tells us a times b is a real number. The commutative property of addition, if I hear commute, I think move. So the commutative property tells us a plus b equals b plus a. The numbers just switch spots, they move. So the commutative property of multiplication says a times b equals b times a. Again, they just switch spots. They move around. So commute to move, our numbers just move around. They change the order. The associative property of addition, if I think of associative, I think of associate, things associate or group together. So A plus B, those are grouped together, plus C equals A plus B plus C. So our grouping symbols change here. First we have A plus B associating or grouping together, and second we have B plus C associating or grouping together. Notice the order stays the same. So for multiplication, our associative property of multiplication says A times B, the quantity, times C equals A times the quantity, B times C. Again, the order stays the same. The grouping symbols are what move. We're associating different things together. The identity property for addition, the identity property of addition says A plus 0 equals A, or the same thing, 0 plus A equals A. I always think we want to keep our identity. So what can you add that gives you the same number? Well, you can add 0. The multiplicative property of identity, again, we want to keep our identity. So you think, what can I multiply by that keeps a number the same? And that's 1. So A times 1 equals A, or 1 times A equals A. So our identity, our multiplicative identity is 1, our additive identity is 0. The inverse property, okay, for the inverse property, if you're adding, you want to get back to 0. If you're multiplying, you want to get back to 1. So if I take a number and I add its opposite, it undoes it. So the inverse, I think inverse undoing. A number plus its opposite is 0. So the opposite of a number is its inverse for adding. For multiplying, the multiplicative inverse is going to be the reciprocal. If I take a number and I multiply by its reciprocal, I'm going to get back to 1. That only works, though, if our number is not equal to 0. So that's the inverse property for addition and multiplication. And our last one is the distributive property. The distributive property is one I'm sure you've heard of. This tells us A times the quantity B plus C equals AB. So we give the outside to both the inside. So it equals AB plus AC. I want you to notice this has parentheses and this has parentheses as well. The difference being we have a number here going to both. There's no parentheses here. Here we have parentheses in both sides. For both of these, there's parentheses in both sides. And then the ordering of the numbers does not change. So that's the difference between the associative and the distributive. I can easily see you mixing those two up. Okay, we're going to end here by doing our so what. What's important to know about this? Okay. We are not going to spend a lot of time on 1-1, but you need to know this stuff for the test. So our so what that I think you'll need to remember the most is you need to know this for the test. Make sure we go back and do some reviewing throughout the chapter on this, but this is something that you need to know for the test. Have a wonderful day.